Hello everyone, my name is Oscar and my teammates are Blair and Lakshay. This is our presentation of our project. PROWL-R is a multi-agent robotics project built in Webots. The objective was two radar robots must cooperate to infiltrate a guarded zone, capture a red flag, and return to their base, while evading a guard robot that patrols and chases them. The project targets option C, multi-agent coordination, meaning the core challenge wasn't just individual robot behavior, but getting the raiders to work as a team. They do this via auction-based role assignments at the beginning of the round, shared guard sightings broadcast over radio so both raiders know where the danger is, yield logic to avoid collisions between teammates, and a heartbeat messages to detect if a teammate has gone offline. Uh, Here we have our contributions. I focused primarily on the robotic architecture, behavior implementation, and navigation systems.
My name's Blair, and my contributions included the initial Webots environment setup, debugging, testing, and simulation refinement.
My name is Lakshay and I contributed to documentation, testing scenarios, report preparation, and presentation support.
Okay, so our system architecture flows as a sense, process, decide, and act pipeline. As the robot moves through the environment, they continuously collect sensor data, process that information, select behaviors based on priority, and then execute actions.
The robots use multiple sensors, including IR proximity sensors, wheel encoders, RGB cameras, compass sensors, and communication modules. These sensors allow the robots to detect walls, identify other agents, estimate their orientation, and coordinate with their teammate.
Whereas the radar robots uses the behavior tree inspired state system with states including seek flag, avoid obstacle, evade guard, recovery, and return to base. This creates a reactive and adaptive autonomous behavior during missions.
The behavior tree shown here is evaluated every time step from top to bottom, with the first valid branch becoming the active behavior. Priority one is avoid obstacle, which immediately steers the robot away from nearby walls or objects using the proximity sensor.
Priority 2 is recovery behavior, which activates if the robot becomes stuck or trapped for an extended period of time. Priority 3 is evade guard, where the raider uses camera perception and teammate communication to avoid nearby guards.
Whereas the priority 4 is return to base, which activates after the flag is captured and when radar enters escort mode. Finally, if no higher priority conditions are active, the robot continues seeking the seek flag behavior and navigates towards the target objective.
We will now demonstrate how our robot project works.
So, this demonstration shows the full autonomous mission in progress. The two raiders begin on the left side of the arena, while the guard patrols the central area near the frag.
The raiders first perform waypoint navigation using odometry and compass heading. Um, the calculations. They dynamically select northern or southern approach lanes using a bidding and coordination system and reduce collision congestion.
When obstacles are detected using IR proximity sensors, the robot immediately transitions into obstacle avoidance behavior. The system also includes recovery behavior such as reversing and turning when the robot becomes stuck.
Uh, the radar robot's using RGB camera processing to identify the guard robot based on its yellow color signature. When the guard is detected, the raiders transition into evade guard behavior and attempt to avoid interception.
Raiders communicate using JSON broadcast messages over emitter and receiver devices. They exchange heartbeat, guard scene, and flag captured messages for cooperative coordination. You can also see the behavior transitions occurring live on screen and in the console, such as seek flag, evade guard, and return to base.
When a radar reaches the red flag, it transitions into return to base behavior. The teammate also enter escort modes and return to base together with the flag carrier.
Our implementation was written in Python using separate guard and radar controllers. The radar controller includes navigation, logic, communication systems, state selection, perception functions, and recovery behavior. We also briefly show the code editor and controller structure during the demonstration. Overall, we successfully achieved the assignment objectives and developed a robust autonomous robotics simulation system.